Hi guys, here I'm going to explain about three topics under reinforcement learning. First, let's enter to the introduction. So, reinforcement learning is a type of machine learning approach to produce a model where uh, the model is taught with some reward-oriented rewards-oriented methods where it's like value-based or rule-based. It's like teaching your dog how to sit, kind of like if you want to teach your dog how to sit, you will say the command sit, and you will have the treat so that if your dog listens to your command and responds it in your way that you're supposed to do, you will give him a treat. So that's how it's supposed to work. So that's how this reinforcement learning works. Under the reinforcement learning, there's this topic called policy gradient, in which they use a set of policy kind of rules, which is represented as a probability distribution. So this policy is kind of the rules which will help to give a reward, so that if that model applies these rules, then it will get a reward, so that that model will get trained as it's supposed to be. So we have to know these five things before entering into the topics: state, action, and reward. So state is which is the current state of the model, and action is the decision which is taken by the model, and the reward is what it uh, gets from the policy by the action which is taken by the model or the decision. So there is this two neural network which are supposed to be used in these topics, which are value neural networks and policy neural networks. So before this policy neural networks, there are only value neural networks, which are used in under reinforcement learning. So value neural networks are one that's supposed to give just rewards when it approaches the goal of the model, and policy is the certain rules which we will discuss further in this topics. So topics that are covered in this video. The first one is proximity policy optimization, and the second one is Actor-Critic, and the third one is A3C, which is asynchronous advantage Actor-Critic. And this is the advanced model of this Actor-Critic. So let's see what's PPO. The core idea of PPO is to make the model to take small steps and update the policy according to it. So let's consider this as a man. Ignore my scribblings. So it has to reach uh, the point B. Okay, turns left or right towards A or C. If it goes towards the B, it should get +1 for every good move and plus -1 for bad move. To be simple, I have kept it as this separate ways. So probably this way would be kind of like messy, not like a single turn to get into the output. So when this human walks straight into this intersection and moves left, it will get on for this for its bad move. So it will be updated in this policy, and it will get updated in the policy, and then it is synchronized to this model, and then it learns that it's not a good move, so it comes back to the intersection, and it tries to go to right. If it tries to go to right, it's a bad move, so obviously it will get -1 for its bad move, and then it will come back to its intersection and it will go to the B. So that's how this policy proximity optimization works. Then let's go to the next method called Actor-Critic. So by moving to the second topic, by its name, we can see that there are two characters in this. So the main characters are actor and critics. So with this, so the actor is the model which which makes the decision, and critic is the one who judges the decision and gives the rewards by the decision which the actor takes. So so this is the model, this is the architecture, how it works. Let's consider this as the environment. Okay. So the state is where the model is pushing. An actor is the process which the model takes the decision, and it takes a decision according to it, and it gives an action, and it gets updated to the environment. So by this action, it goes again. It just copies. It just duplicates to the state, uh, and then it is sent to the critic to evaluate the decision of the actor, and then it gives a Q value, which is uh, which is not +1 or -1 as we saw in the previous section. Uh, it is like a percentage of how good the move is. So by this this Q value is getting updated to the actor so that it will uh, get to know all whether that action or the decision which it took is correct or not, or how good the decision or how bad the decision was. Next, okay, coming to the next topic, A3C. Okay, A3C is kind of it's an advanced version of the uh, actor-critic method, as I mentioned before. So let's consider this as a local model. So this is the local model where uh, every every environment will be under the local model, and every local model will have a certain policy, and it gets updated, uh, and it is asynchronously connected to the global one. This local environment will do every experiment, and it will get updated every sequentially, like consecutively after every process, and then even after every process, it gets updated to the global, so that uh, this global will get trained by different experiments at the same time, so that this process of actor critic method is getting optimized, and it can be implemented uh, as soon as possible.